welcome back to the last two targets of Project 1, where we're going to learn how to write the equation of a line of best fit and then use that equation to make predictions. All right, so in this lesson, I'm going to be using the Desmos graphing calculator. So if you do not have that app yet, go download that now. All right, so we're going to do the following example on this Desmos graphing calculator. I'm going to split screen on my iPad to do it. All right, so now I'm on my iPad and I have this problem pulled up on Notability. What I'm going to do is I'm going to split screen with this Desmos graphing app. So I'm going to pull this up and now I'm split screening. I'm going to take some time now to type in that table that we see here in Notability. I'm going to type that in my Desmos graph. The way you do that is you are going to press the plus button and pick table, and then you're going to fill in the X's and Y's. I'm going to do this and then come back, and you could pause the video here and type them in yourself so you can follow along. All right, so now I have my table filled in, and you don't actually need to see this graph in order to do the next step, but I'm going to quickly tweak my settings to show you what this data looks like on the graph. I changed the settings a little bit, and this is the visual of how these points land on the graph when we actually graph the scatter plot. But that's not really the task I need. What the problem asked us to do, if we look back on Notability, is the problem asked us to find this equation. We want an equation in the form of y equals mx plus b for the regression. It's in the form of y equals mx plus b because it's a linear regression and all lines can be written as y equals mx plus b. So if I switch back to my Desmos graphing calculator, here's the big thing you need to know. We are going to type in the following formula into Desmos, and it is going to do the rest for us. We're going to type in y1. You don't even have to do anything special to make that one go down. We're going to hit ABC, and we're going to find the special tilde, which is right under the B and N. Then we're going to type in mx1 plus b. That is the formula Desmos looks for in order to produce the regression equation. And as you see over here in the graph, they now have a line of best fit drawn through the lines, so a linear regression has been performed. We're going to take some of these details over here on the left in order to go and find our actual regression equation. So I'm going to switch back to split screen here with Notability. And I'm going to copy over the M and the B of the parameters in that box that we just created. So we want y equals mx plus b, but we know from that box over there that m is negative 44.1256. So it's going to be y equals negative 44 point, and I'll do some rounding, 13 x plus 407.77. And that is a regression equation. So this is the process we're going to use to go and find the equation for the line of best fit. So let's do one more example of getting this equation and then using it to make a prediction. All right, so here's an example comparing the quality score of a television to the price that it's marketed at. And I already typed all of my data table into Desmos. So if you haven't done that already, pause the video, do it, and come back. So what we are going to do here is we are going to try to find that regression equation. We're going to identify something new, whether or not the relationship is strong or weak, which I can explain to you pretty quickly. And then we're going to use that equation to make a prediction for an unknown data value. So what I'm going to do is I'm going to go and type my equation, which we learned was y1 tilde mx1 plus b. And that gives me all of the information I need. So I'm going to copy over my equation, which will be in y equals mx plus b form. So it'll be y equals the m, which is 51.1, x plus the B, which is negative 1,233. So if it's plus a negative, it's going to be really minus 1,233. And that will be our regression equation. Now, as far as whether or not this is strong or weak, we are going to look at R. So I moved this table over from Desmos into my Notability file so I could point this out. In this table, they're going to give you a value here for R. That tells us everything we need to know about our relationship. So I'm going to make this little table here. It says if the absolute value of R is less than 0.9, if the absolute value of R is greater than 0.9, and if R is positive or if R is negative. If R is negative, that means we have a negative relationship. If R is positive, we have a positive relationship. Now, if R is smaller than 0.9, the number part of R, that's why we have absolute value there. If the number part of R is smaller than 0.9, that makes this weak. So we have a weak positive or a weak negative. And if the number portion of R is greater than 0.9, we have a strong positive or a strong negative. Because this problem had an R that was positive but smaller than 0.9, that means that we have a weak positive relationship. So I'm going to move that up here and say that this is a weak positive relationship. Now finally they ask us to make a prediction for the cost of a 90 quality score television. Well, quality score is up here in our inputs or our X column or row in this case, and money is in our Y column or our outputs column. So when you tell me that the quality score is 90, what that's saying is that X equals 90. And they want to know what's Y equal. So we're going to use this equation. Y equals 51.1 times X, which we know X is 90 for this question, minus 1,233. Going back to my graphing calculator here, I'm going to ask it what this is. So 51.1 times 90 minus 1,233. We hit enter and we get 3,366, which, because we were asked what's the cost, this is money we're talking about, so it would cost $3,366. If they were to give us a similar problem and give us the cost of a television and ask us to predict the quality score, they would be giving us a Y, not an X. So we would plug whatever number that was in for Y, and in that case solve for X instead. So it's a very similar process with a little bit different solving. So to summarize this lesson, linear regression is all about explaining data that we've already seen and using that explanation to make predictions about other X values we don't already know about. If you came away with any other big observations, write those down now. Otherwise, we'll see you next time.